Section 8.2, question P16. So we have a student doing a 40-question true-false test and getting 30 answers correct. Now the student says, proves I wasn't guessing. So what's the standard P null, I guess? P naught is what we often say. Well, on a 40-question true-false test, actually it doesn't matter how many questions. On a true-false test, since there's only two possibilities, 50-50 chance with a random guess, so 0.5 is the standard, which would be the null hypothesis as we look into inferential tests. Should this be a one-sided or a two-sided test? Well, the student is claiming that he was not guessing. In other words, he's claiming that he got 30 answers correct using some amount of mental ability, not purely randomly guessing. And if that's true, if he really was using some mental ability, his should be greater than the 20 that we would expect by chance. So we're really only concerned with whether or not it's 20, if it's greater than 20. In other words, we're only concerned with that one side of the test. It's not if he just got 10 correct and said he wasn't guessing. That would seem strange because he got less than the amount. So we're really only concerned in this case with whether or not he got more than, not whether he got a different number than the expected amount. So one-sided. The null hypothesis, as we mentioned up here, is 0.5, so truly randomly choosing on a true-false. Assuming there's roughly the same amount of each, we should get 20 correct. And his alternative hypothesis, because it's one-sided, is going to be greater than 0.5. In other words, if we reject the null, then we're going to settle. It doesn't prove anything, but we're going to end on going with an alternate hypothesis, which is that he really did know some of what he was doing. What is the sample proportion? This is 0.75. Notice that the sample we're talking about here is the student himself, or I guess herself. Getting 30 answers out of 40 would give you a 0.75. And so we're using this figure below. What is this? Well, it's normal, or at least an approximately normal distribution. But what's going on here? Well, we have 0.5 as our null hypothesis proportion. In other words, randomly we would expect the student to get about 0.5 of the questions right, and that's the most likely here. That's the center of our distribution. As we go out further away from the mean, we decrease. How are we knowing how much to decrease? Well, that depends on the standard error. So it depends on our sample size, which in this case was 40. We have 40 questions, each of which could have been true or false. And then the sample proportion was 0.75. Of course, 1 minus that would be 0.25. So we could use those. Although really, the question just asks us to look at this visually. So looking at this example, his or her 0.75 would come right here, which does not seem to be coming from this distribution of randomly guessing. This is the distribution if you completely randomly guess, and if it's roughly the same number of trues as falses on the test. So 0.75 doesn't seem to belong to that distribution. It's much more likely there's another distribution, kind of invisible here, where the student does know some of the answers. So there is strong evidence that what guessing. Does it prove? No. Prove is a dangerous word in statistics. So even though it's very unlikely, and we could calculate that. We could calculate using the standard error and the 0.5 here. We could calculate how unlikely this was, but it certainly doesn't prove, no matter how small the possibility is. You can picture a little tail going out here, very thin, but it does exist.